During World War II, destroyers played a crucial role in naval operations as versatile warships capable of escorting larger vessels, hunting submarines, and engaging in fast attacks. They were the workhorses of the fleets, protecting convoys across treacherous seas and serving as the first line of defense against air and surface threats. However, not all destroyers were created equal. Many nations, in their haste to expand their navies, designed ships that looked impressive on paper, but failed miserably in combat conditions. Flaws ranged from structural weaknesses and poor seaworthiness to unreliable engines and inadequate armament. Some designs even endangered their own crews due to stability or safety issues. This essay explores 5 of the most flawed destroyers of WWII. Ships that fell short of expectations and highlighted the challenges of balancing speed, firepower, and durability in wartime naval engineering. From Japan's overly ambitious Shimakaze to Britain's underperforming Hunt-class. Each of these destroyers represents valuable lessons in the dangers of flawed design choices, rushed production, and the high cost of war-driven innovation. When Japan introduced the Fubuki-Class destroyers in the late 1920s, they were considered revolutionary. With heavy armament, high speed, and long-range torpedoes, they outclassed all contemporaries and forced other navies to re-evaluate their destroyer programs. However, by World War II, the design's limitations began to show. The Fubukis were too ambitious for their size, carrying more weapons and equipment than their hulls could safely support. This led to serious stability problems, especially in rough seas. Several ships were lost or damaged in non-combat incidents because they became top-heavy and capsized during typhoons or after battle damage. Efforts to retrofit the class with more anti-aircraft guns and radar systems only worsened these problems. Additionally, their lightly built hulls made them vulnerable to depth charges and near-miss bombs. Although they were formidable offensively, their lack of survivability in prolonged engagements revealed a fatal design flaw. They were powerful but fragile. The Fubuki-Class showed that innovation without structural balance could turn an engineering triumph into a strategic liability during wartime. Britain's Hunt-class destroyers were conceived as a response to the pressing need for convoy escorts during WWII. Unlike fleet destroyers, the Hunt-class was designed for economy and quantity over performance. Unfortunately, this philosophy produced ships that struggled to meet operational demands. Early versions suffered from severe stability issues, forcing designers to remove one of the main gun mounts to reduce top weight. Even after modifications, the Hunts were underpowered and slow compared to enemy destroyers, limiting their ability to pursue or evade threats. Their range was also limited, restricting them mainly to coastal or short-range convoy duties. While they performed adequately in the Mediterranean, they fared poorly in rough Atlantic conditions. The cramped crew accommodations and minimal anti-aircraft weaponry further reduced their effectiveness as the war progressed. In essence, the Hunt-class destroyers were examples of compromise gone too far. They could escort convoys but lacked the versatility and resilience of true destroyers. Britain's urgent wartime needs justified their production, but the ships themselves highlighted the risks of prioritizing numbers over quality in naval warfare. The United States Navy's Sims-class destroyers represented an attempt to improve on earlier designs like the Porter and Mahan classes, but the result was a ship plagued by balance and design flaws. The main issue was weight distribution. Designers tried to fit more machinery and heavier armament into a hull not designed for it, leading to stability problems and reduced performance. As a result, the Sims-class ships were top, heavy and prone to rolling, especially in rough weather. To correct this, the Navy had to remove equipment and modify superstructures, but the fixes were only partially effective. Furthermore, these destroyers were built just before the US fully adopted radar and advanced anti-aircraft systems, leaving them poorly equipped when war began. They were neither fast enough to operate effectively with carrier groups, nor durable enough to withstand heavy action. While some Sims-class ships performed bravely, such as USS Sims at the Battle of the Coral Sea, their design flaws limited their long-term value. The Sims-class taught the US Navy the importance of integrating firepower, stability, and future adaptability in shipbuilding. The Soviet Gnevny-class destroyers were based on an Italian design, the Fubuki-Class, but Soviet engineers modified them so heavily that they lost much of their original balance and efficiency. The ships were intended to be fast, sleek, and well armed. Instead, they turned out unstable and mechanically unreliable. The addition of heavier Soviet weaponry increased the ship's displacement beyond safe limits, making them prone to capsizing in heavy seas. Their engines, often poorly manufactured, suffered frequent breakdowns, and their fuel systems were inefficient. Moreover, the class lacked proper damage control measures, so even minor hits could cripple or sink them. During the early years of the war, several Gnevny-class ships were lost to mechanical failures rather than enemy fire. The crew conditions were also harsh due to poor ventilation and cramped design. Despite their impressive speed on paper, their real-world performance was disappointing. The Gnevny-class reflected the Soviet Navy's struggle to modernize rapidly without sufficient industrial and design experience, resulting in a fleet of destroyers that looked formidable but performed unreliably under combat conditions. Italy's Soldati-class destroyers were among the most stylish ships of WWII, showcasing sleek hulls and elegant lines, typical of Italian naval design. Yet beneath their graceful appearance lay several serious flaws. The Soldati-class prioritized speed and aesthetics over practicality. Their light construction made them fast but fragile, and they lacked adequate armor or compartmentalization for damage control. Their limited operational range also prevented them from conducting long missions, restricting them mostly to the Mediterranean theater. Another issue was their poor anti-aircraft capability, an unforgivable weakness in an era when air power dominated naval warfare. Their torpedo armament was decent, but they often failed to score hits due to weak fire control systems. Additionally, maintenance was difficult due to complex machinery and a lack of spare parts. Many Soldati-class ships were lost to air attacks or mechanical breakdowns rather than naval combat. Despite their speed and beauty, these destroyers demonstrated that elegance could not compensate for durability and adaptability. They remain a symbol of how aesthetic priorities and limited resources can cripple a navy's operational effectiveness in total war. The Japanese Shimakaze was a one-of-a-kind destroyer meant to showcase Japan's naval innovation. Designed to be the fastest and most heavily armed destroyer in the world, Shimakaze featured a revolutionary high-pressure steam turbine system and carried an astonishing 15 torpedo tubes. However, these advancements came at a steep price. The new turbine system was overly complex and prone to breakdowns, making maintenance difficult in wartime conditions. The ship's extreme speed, over 40 knots, strained the machinery, and her heavy armament made her top heavy. Moreover, Japan could not produce the experimental turbines, meaning Shimakaze remained a single prototype rather than a full class. Despite her impressive power, she lacked balance and reliability. During her brief career, Shimakaze saw limited success before being sunk by American aircraft in 1944. Her ambitious design symbolized Japan's pursuit of technological superiority without considering practical wartime needs. The Shimakaze's failure underscored that innovation must align with sustainability, an important lesson ignored by Japanese naval planners as resources dwindled and maintenance became impossible under constant Allied pressure. Germany's Type 1936A destroyers, known as the Narvik-class, were among the heaviest and most powerful destroyers of WWII. They carried 150 WWII guns, larger than any destroyer armament of the time. But this impressive firepower proved disastrous. The heavy guns were unsuitable for fast maneuvering and made the ship's top heavy and unstable. Additionally, the engines were overly complicated and unreliable, leading to frequent mechanical breakdowns. The ships had limited fuel capacity, restricting their operational range and making them unsuitable for Atlantic operations. Their large size and poor handling also made them easy targets for aircraft and submarines. Many Narvik-class destroyers suffered from poor seaworthiness, especially in rough northern waters, where they rolled heavily and even lost weapons overboard. The class's excessive focus on gun size overbalance made them a case study in over-engineering. Although they looked formidable on paper, their actual combat performance was inconsistent at best. The Narvik-class destroyers epitomized the German Navy's tendency to prioritize technological showmanship over practicality, resulting in ships that were powerful but inefficient and dangerously unstable. France's Le Fantasque-class destroyers were among the fastest warships ever built. Reaching speeds of up to 45 knots, they were intended to act as counter-torpilleers or super-destroyers, capable of hunting enemy destroyers and even light cruisers. However, their focus on speed came at the expense of endurance and reliability. Their engines were extremely powerful but consumed vast amounts of fuel, giving them poor operational range. This made them unsuitable for long missions or Atlantic operations. Their thin hulls and light construction also made them vulnerable to battle damage. Although they were well armed, their limited anti-aircraft defenses left them exposed to air attacks. Maintenance was another major problem. Complex machinery and insufficient spare parts often kept them docked for repairs. Despite their record-breaking speed, the Le Fantasque-class destroyers struggled to make a significant impact during the war. They represented a classic example of how extreme design priorities, such as speed, can undermine overall combat effectiveness. These destroyers were impressive in trials, but impractical in prolonged, real-world naval operations. The 5 most flawed destroyers of World War II, along with others like the Shimakaze and Narvik, demonstrate that naval design during wartime is a delicate balance between innovation, reliability, and practicality. Each flawed ship reflected its nation's strategic mindset and industrial limitations. Japan's obsession with speed and torpedoes led to unstable, hard-to-maintain ships. Germany's over-armed destroyers revealed the dangers of engineering excess. Britain's and the Soviet Union's attempts at cheap mass production created underperforming vessels. Even the United States, with its advanced industry, struggled to balance firepower and stability in some early designs. The ultimate lesson is that a destroyer's value lies not in record-breaking specifications, but in consistent, dependable performance under combat conditions. War punishes excess and rewards balance. The flawed destroyers of WWII remain important case studies in naval history, not merely as failures, but as reminders that engineering brilliance must always serve strategy, logistics, and survivability. From these mistakes, post-war naval designers learned to prioritize adaptability and balance, leading to the far more effective destroyer classes of the Cold War era.